Hello friends, myself Rajendra Mahajan presenting my one more video on linear algebra. Example, define invertible matrix. First question, define invertible matrix. Second, if A and B if A and B are invertible matrices are invertible matrices if A and B are invertible matrices, then prove that AB and its inverse is equals to B inverse into A inverse. And to prove this, first of all, we define that invertible matrix. An invertible matrix is a square matrix of order n by n that has an inverse. Means if inverse exists, then that matrix is said to be an invertible matrix. This is the definition. For a given square matrix of order n by n, and that matrix we call as capital A, there exists it is invertible if there exists matrix B, another matrix B, and that is also square matrix, such that A into B is equals to B into A, and its product is I. If product of two matrices is identity matrix, then B is called as the inverse of A. That is, B is inverse of A. This is the definition, all of you are knowing. That is, if we replace by B by A inverse, we get A into A inverse is equals to A inverse into A, and that is equals to I. Identity matrix. Inverse of A exists only if the determinant of that matrix A is not equals to 0. If determinant of that matrix is not equals to 0, means that matrix A is called as non-singular matrix. Non-singular matrix means that invertible matrix is also a non-singular matrix. Let consider two matrices A and B as invertible matrices. Then by definition, if product of AB inverse is the invertible, inverse is the in if AB inverse is the inverse of AB, then AB multiplied by that AB inverse, product of that is I. A into A inverse is equals to I. This is the property. We know that AB inverse as B inverse into A inverse, property of inverse. And therefore, substituting that AB inverse as B inverse into A inverse in equation 1, and then using the associative law for the product, associative law for the multiplication of two matrices, associative law of multiplication, we can rewrite that as, above step we can rewrite as A into, in bracket, B into B inverse, bracket close, and into A inverse. This is as per the associative law. Then it is equals to B into B inverse is nothing but I. Therefore, it is A into I, identity matrix, into A inverse. Since that B into B inverse is identity matrix. Then any matrix multiplied by identity matrix, we get the same matrix, and therefore that A into I is A into A inverse, and the product of A into A inverse is I. And the reason for that step is, since A into A inverse is, A into I is A. That is, AB inverse is equals to B inverse into A inverse. Hence proved. This is the required result. How? As we are getting a product of AB into B inverse A inverse as an identity matrix, that means if we transfer that AB to other side, we get B inverse into A inverse is equals to AB inverse, or nothing but AB inverse is equals to B inverse A inverse. That is the required result. Please like my video, share it, as well as subscribe to my channel, and to receive the notification, please press the bell icon. Thank you. Thanks for watching.